Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. I'm Dr. Elena Hyde, and I'm joined tonight by the amazing Robin Metcalf. That's right, she's come back again, starting to be a real regular here on York Universe. So great to have her back on the show. Now, as a reminder, we are, in fact, broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. UT if that's more your speed. York Universe production works in concert with our online public viewing program run by our amazing observatory team. So if you're watching this live on YouTube, you're already in the OPV actually, which runs between the same time, 9 to 10 p.m. local Toronto time. If you want more about OPV or you want to find previous episodes, you can always go to our website, yorku.ca/science/observatory. You can follow the links to OPV online public viewing or click on any of our YouTube links to reach our channel. If you have any questions or comments about our past shows, suggestions for future topics, or anything else you would like to ask us, you can email us at observe@yorku.ca. And you can also connect with us on social media. We have Instagram at York U Observatory and Facebook at Allan I Carswell Obs. And all of our programs, including this one, are free, but if you'd like to make a donation, support our endeavors, or buy some really cool observatory swag, you can see that same website I mentioned before, yorku.ca/science/observatory. Now, as I mentioned before, we have Professor Robin Metcalf from the Natural Science Division at York University. And if you've missed her previous episodes, well, definitely go back and check them out. They're pretty cool. But she's actually been teaching astronomy for over 20 years. She has a PhD in extragalactic astronomy, and she's been on the show talking about all kinds of things as well as on our Astronomer in Residence program, so you'll be able to look forward to more vlogs from her this summer out at Killarney Provincial Park. So welcome back to the show, Robin, and great to have you here.
Thank you so much. I'm in my office at York. I was supposed to be at the Blue Jays game tonight. I got a last minute invitation yesterday from a friend, and I tried to think of a way I could do both. Like I said to her, is there some quiet area I can go to for an hour at the Jays stadium and do this? And the best we could come up with was like the bathroom, but that could be awkward. So, so I skipped the game.
Oh my gosh. Well, hopefully we can keep you entertained with astronomy to make up for it. um, that's true dedication, folks. You heard it here first. And of course, we do hope to bring some live images tonight. We have been watching some weather systems come and go in Toronto. It's currently reading as clear but also rainy on the telescope weather sensors. So the rain condition is preventing us from opening, but if it does change, we will start showing live images on our online public viewing tonight. So stay tuned, everybody. We'll keep you all posted. Now we've got all kinds of great things planned for tonight. We have quite an episode lined up, I think. Um, I thought I would start us off with a little bit of this week in space and astronomy history, going back in time and focusing on something that is actually up in the sky, if you are willing to stay up until the morning, Mars. So I'm going to go back and start us off in 1964. 1964, very strange time, but June 4th, so keeping with the theme, I had to check twice. It is, in fact, June already. So watch out, folks, don't get caught out. So plus one day, and back in 1964, there was a birth, launch, and death of a little probe that probably didn't get very much press at the time, but really actually played a large role in our Mars exploration. This was the Soviet Zond, that's Zond with a Z, 1964A, and it launched on the 4th of June, 1964. So it's born on that day, and it did lasted about 104 seconds. So it actually failed to achieve Earth orbit. It had a faulty valve and it failed after about 104 seconds after launch. And so this was a shooting star, if you will, but going the other direction. And it was an interesting mission in a lot of ways because this was just after, of course, they had the Mars One, and this was one of the first Soviet missions that actually explored Mars. So we had Mars One getting us some initial pictures. And this was if you don't remember, this was back in 1962, so this was 2 years earlier, before the rather ignominious launch and explosion of Zond 1964A. Mars 1 was an interplanetary spacecraft that was launched in 1962, and it was the first probe from the Soviet Mars probe program that actually achieved interplanetary orbit. So it did get a little bit of fame. It was intended to fly by Mars at about 11,000 kilometers, and they were hoping that it would take back, of course, imaging and tell us about the red planet. This was an interplanetary, sort of station launched in the direction of Mars. And they were hoping it would also measure things like cosmic radiation, micrometeorite, sorry, that's a difficult word to say tonight for some reason, and magnetic field and all kinds of other things. But the spacecraft was on its way to Mars when it actually stopped talking back to us. So its communication ceased, and it had a closest approach in June 19th of 1963. So a different This Week in Space and Astronomy June day. But it got to, we think, about 193,000 kilometers. And then it wasn't talking to anybody anymore, so they couldn't do anything to control it. And it basically entered an orbit going around the sun. It did have a lot of cool equipment with it, and it was able to actually send us back some measurements of the solar wind and some records of micrometeorite strikes, which is one of the things you do have to worry about with spacecraft even today. And so this Zond program was a kind of a follow-up. It used a different launch vehicle, and they had a lot of failures. It's worth noting that in the early exploration of the solar system, these early launches, a lot of them did not work. So you had a lot of failures for a little bit of success, and the Zond with its launch vehicle, and its rockets just did not make it. The 1964A. It was closely followed up by another rocket just a little bit later. This was a Zond 2, November 30, and this was part of the same program. Zond 2 actually had a similar fate to Mars 1. So it got out and it actually made it away from Earth, didn't burn up, didn't explode, but it also lost communication en route to Mars in a mid-course maneuver. So they were trying to change its direction, and Zond 2 was actually the sixth Soviet spacecraft to attempt a flyby of Mars. And well, it got towards the general direction, but they also lost control of it, and it didn't quite make it. So in the early 1960s, there was a lot of, um, I suppose, trouble with spacecraft control. And the Zond 2 actually did have a camera, so if it had managed to make it there, it might have even managed to get pictures of Mars. And of course, in the early 1960s, all in, the Soviet Union at the time launched 9 probes to reach Mars. So the Zond, as I say, this week in space and astronomy history, the Zond failed, but all 9 of the Soviet probes in the 1960s, from 1960 to 1969, they all failed. So 3 failed at launch, 3 failed to reach near Earth orbit, and 2 during the interplanetary orbit. The Mars 1M was probably the closest success, because it did, of course, go into orbit around the sun, and it did have a closest approach to to Mars. So the this was an interesting time in the space race and an interesting day in history, I suppose. Of course, Mars exploration by the Soviet Union would continue um, uh, up through the 1970s. They wanted to get the first artificial satellite of Mars to beat the American Mariner 8 and Mariner 9, which were intended to also go into uh, um, sorry, Mars orbit, I should say. But it was an interesting time. Mariner 8 actually didn't make it either, but Mariner 9 was an early Mars success. So Mariner 9 wasn't until 1971, I believe, or 1971, 1972, something like that, part of the Mariner program. And of course, it had to deal with planet-wide dust storms on Mars, which, if you've ever heard of Mars, happens every once in a while and really stops you from seeing any kind of details on the surface. So, this week in space and astronomy history, a bit of fun, a bit of back in time. Have you ever done any Mars history, Robin?
Yes, we do. In my spaceflight class, we talk about those or the milestone missions to Mars and a little bit in history of astronomy as well.
It's always fun, and it is always fun to me to just see how, I don't know, I wouldn't say necessarily duct tape and shoestring, but
Mm,
they were definitely flying by the seat of their pants on some of these missions, and I'm very glad that these ones were not crewed because a lot of
yes.
them
Yeah, it almost makes you think that those early Apollo missions of actually getting a person to land on the moon was like the moon, of course, not Mars, but miraculous, really. When you think of the statistics of all the failures of going to Mars and even just, launching period to the moon, the fact that the one time that we wanted to send a person to actually land on the moon, that it actually worked
Yeah, well, I mean,
is
they
pretty
they did have
miraculous.
a lot more safety protocol for those missions than for the satellites.
Hmm.
For good reason, because of course, once you actually have humans involved, you have to be much more careful with your engineering. You can't just launch a little camera and hope for the best.
Hmm.
So I mean, but that's why the lunar program was incredibly expensive. Um, Part of the reason, anyways.
Yeah, we have
I don't think we have
yet,
time to get into the finances.
yeah, we have yet to lose a human in space. Pretty amazing. Oh, well, sorry, that's not
Uh,
totally true. I mean, obviously on, the launches and stuff like that, but not actually in space.
Yeah, I mean, we've had a lot of spaceflight related accidents and
Right,
incidents.
right.
I heard that we've had something like 5 fatal space missions.
All like
So
on launch and landing, right? No,
yeah,
we've
so
never actually lost someone in space, I guess is what I'm trying to say.
well, I'd have to go back and count them, but I think it sort
Hmm.
of depends on how you write the low Earth orbit, because of course the was it that hydrogen gas that happened in the
Right,
capsule.
right.
And I mean, a lot of them, reentry and launch are the
Mm,
most dangerous parts of it because
yeah.
Earth's gravity is no joke.
Hmm.
Turns out our planet has, for us, plenty of gravity, and I mean, we're all familiar, of course, with Columbia and Challenger, and
Right.
um,
Yeah,
but
I mean, I
yeah.
realize it's sort of a dark topic that we don't need to get into right now, but it is sort of interesting to think about how humanity would respond to something like that happening.
Yeah, and it is, well, we did just last year have a proposal where several people tried to use a private company to send their remains to the moon. And this was
Hmm.
cremated remains. And it is
Hmm.
something that there do seem to be a lot of people interested in, because we do now have private companies that can send things to the moon. And I mean, if you wanted your cremated remains to last forever, I suppose
Yes, well,
That
actually,
would be
I
one way
don't
to do
know
it.
if you remember Professor John Caldwell from York. That was probably before your time, but when he passed away, his family had his ashes launched into orbit around Earth.
Oh, I don't remember that one, but I did hear about James Doohan, the actor from the original Star Trek series,
Uh-huh, uh-huh.
who had his ashes, and I believe he had a portion of his ashes launched a couple times, and it took more than one. But
Mm-hmm.
the folks who had their ashes launched last year were a bit out of luck because that did not make it to the moon.
Ah.
um, but yeah, it is a bit of interesting trivia, I suppose, that the fatalities during space flight tend to occur when you're, landing or re-entering, as they say, or launching off.
Mm-hmm, mm-hmm.
And I think, if you were going to look at it, you should also probably include some of the folks who did not make it through various training and testing
Of course.
exercises.
Yeah, like
Um,
in the fire in the early Apollo missions and stuff like
yeah,
that. Yeah.
the Apollo 1 mission was
Mm-hmm.
pretty famously almost stopped before it started.
Mm-hmm. Mm-hmm.
But yeah, there've been some. It is worth remembering. It is a very hazardous pursuit, and the environment of space is so extreme. And when we talk about things like, the moon and Mars, the extreme nature of those environments is really, really interesting, because it's just so different from anything we're used to here on Earth.
Mm-hmm. I always find that such an interesting question to ask people, like just out at the pub or something, like, would you be one of the first colonists to go to Mars? I should not colonists, sorry, but just like, someone that among the
Oh
first
yeah,
group
like
that
if you
goes there.
could, yeah, if
Yeah.
you could go to
It's
Mars
so interesting to
and
hear people's answers. And a
and
lot of
have
people say yes,
yeah, well, a lot of
knowing that
people
wouldn't necessarily come
absolutely.
back.
Yeah, and people have signed up for things. So just watch out for the scams, guys. There is currently no valid or recognized path to live or reside on Mars. So if anyone tries to sell you a place on a spacecraft,
Is that actually happening?
yes, it famously happened in a big way with two different companies I forget the names of, but they took a huge amount of donations, millions of dollars, and again, finance versus astronomy. But they were selling places on their Mars habitation mission or something.
Get
And
out. That is
yeah,
crazy.
and they had at some point they even had sort of pre-astronaut selection, and people were going through training, and uh, there are that many people interested in it. I don't
Hmm.
think it would be, if there was a valid way to do it where you actually had, um, everything that you would need, and you're setting
Right.
up a settlement on Mars. The humans being interested wouldn't be one of the problems.
True.
the
So, Elena, would you go?
Oh, absolutely. I've been planning this for
Really?
years. I've been
Would you
planning
go
this
in
for
the
years.
very first mission?
Okay. So I think I know enough about Mars now that I would be I would need to see the mission specifications.
Okay. I should hope so.
So show me a mission specification that will work, and I will
Uh,
go. Um
okay.
and
Wow. Good for you. That's amazing.
and it is fun to think about because, of course, as our nearest neighbor planet, I mean, other than the moon, Mars is the next thing that we could actually go to and put our boots down on inside a
Hmm.
spacesuit. And Mars does have a little bit more gravity than the moon. It has a little bit more magnetic field than the moon. It might be a little bit easier to set up there, and people have been doing experiments growing food in Martian soil and using elements that are known to be abundant on Mars to produce water and fuel. So it's an interesting thought experiment, and it gets me to the second this week in space astronomy history that's Mars
Hmm.
oriented, because this week I actually found two on June 2nd, which is yesterday, in 2003. So basically not that long ago. Like it's 20 years ago. It doesn't. It seems like yesterday to me because I'm not that young anymore. Uh, anyways, this was ESA Mars mission, the Mars Express, and Beagle 2, and this was a really interesting one because in 2003, by that time we knew more about Mars. We knew that it looked a bit a bit more so I say rocky and dry than other people might have wished for. But the ESA, or European Space Agency, had this wonderful mission, which was the Mars Express and the Beagle 2 together. And the launch date was June 2nd, 2003. Now, the lander actually didn't make it. It was lost on arrival on December 25th, 2003. However, it was a two-part mission, and the orbiter not only completed its primary mission in 2005, not only got an extended mission, but the orbiter is still going today. And I did check it on the ESA website. The mission for the Mars Express science is still listed as status in operation. It's been targeting Mars's atmosphere, surface, and subsurface, Mars's moons, Phobos and Deimos, and its technical arrival is still listed as December 2003, but it's been going for over 20 years. If
Hmm.
you had gotten in on this mission as an undergrad or a PhD student, you would have picked an amazing career opportunity because it's been studying Mars's innermost moon Phobos in unprecedented detail. It's been tracing the history of water across the surface of Mars, and it has really played a huge part in demonstrating that Mars once had environmental conditions that may have been suitable to life. In particular, that Mars once had abundant surface water and may still have abundant subsurface water, which is a little bit related to our story for today, actually.
Hmm. Do you know why the lander was named the Beagle?
I At first I thought it was an acronym, but I looked it up and I couldn't find that it actually stood for anything. So
No,
I'm gonna
it's
go ahead and say it's just a fun name was my guess.
no, it's named after a boat, the HMS Beagle. And
Oh, that
that
makes
is
sense.
it's the ship that Charles Darwin, the British biologist, sailed around the world in the 1830s. And on that voyage, he developed the theory of evolution by natural selection. And because the Beagle 2 was designed to search for evidence of past life on Mars, similar to Perseverance, it made sense to name it after the person who had made such a long-standing contribution to the theory of where life comes from.
And of course it had to fail, so it had a bit of survival of the fittest happen to it
Yeah.
on the
Yes.
on the landing. But at
Possibly an
least the
ill-fated
orbiter.
name.
Yes, a little bit ill-fated name. Good, great idea though, because
Hmm.
it did have a lot of really cool tools on board, in terms of the ability to take samples from rocks. And as I recall, they were using on the landing. This was the parachutes and airbags, so that would have been the inflatable sort of bouncy ball that sort of inflates around the lander. And
Hmm.
recently, of course, we've seen these very elegant, controlled landings of large, complex crafts. But early landings was, parachutes and a big ball, and you hope it doesn't bounce where it shouldn't.
Hmm.
And they've actually conjectured with the spacecraft that they think that the balloons that were supposed to inflate around it basically deflated, and
Ah.
that was why it didn't survive landing on Mars. So once again, the landings are a problem.
Yeah, I'm sure you've seen those computer generated videos of rovers on Mars bouncing around before they come out of those of the airbags. And because we obviously when the landing is going on, we can't actually see it, right? but the CG versions of them, you just watch all that bouncing going on, knowing that there's like $1 billion, tech robot on the inside, and it's just it looks miraculous that it can survive. As you said, like it could hit anything.
Yeah, it
I
could
mean,
bounce
they
into a
choose the
crater.
landing areas, to try to minimize that, but really, all that bouncing around just looks crazy.
Yeah, and I definitely recommend people to check those out. I know ESA and NASA both have a couple versions of those
Hmm.
mock-ups. Of course, now that we have the high-res camera taking pictures of Mars's surface, we do actually have some pictures of sort of during, before, and after the more recent landings, which is just we're
Hmm.
spoiled. We're
Hmm.
so spoiled right now for Mars pictures. Anyways, this week in space and astronomy history, 2003. It is, still running. So Mars Express still going. This is an amazing value for money because it has lasted an incredible long time. And I will just say for the Mars Express, it is actually the second longest surviving continually active spacecraft in orbit around a planet other than Earth.
Hmm.
So the only other spacecraft that beats it for being in orbit around something not Earth is the 2001 Mars Odyssey, which
Hmm.
was a NASA spacecraft that's also still going. And it also got its name from somewhere else. It got its name from the movie. So
Hmm.
Space Odyssey. And it's the Odyssey has detected a large amounts of hydrogen within a meter of the planet's surface. So that's why I mentioned subsurface water earlier, because of course Mars having subsurface water is one of the things that gets folks very interested.
Hmm.
All right, so that's our space and astronomy history recap, I suppose. A little bit of a blast from the past, a little bit of I suppose, Mars fandom happening here because it has been my favorite planet for a while. But no skin off of the Earth's nose, I suppose, because the Earth is still where we all live. Now, I do have a couple little reminders, but I think actually before we get there, I'm going to go ahead and just do our sound bites real quick before I forget about them. So we're about halfway through, and everyone, you are listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you're curious about our show or want to see our wonderful archive episodes, you can go to yorku.ca/science/observatory for chat, questions, or content. And of course, you can always find us on Instagram and Facebook as well, just in case you want all the updates. Now, tonight you're listening to Dr. Elena Hyde and Professor Robin Metcalf, and we're currently discussing lots of Mars This Week in Space and Astronomy history, but we will get on to some fun news items shortly. Now, before we get there, I just have a quick update for everybody. This is the 3rd of June for this episode, and I do have to remind everyone that if you are planning on coming to an in-person tour, this week at the Allan I. Carswell Observatory, we will, in fact, all be away at CASCA, the Canadian Astronomy Conference. So if you're thinking about coming to the observatory, make sure to check that same website I gave you before, and you'll see all the tickets start next week. That's because this week we're out at Casca with our Eclipse Outreach and Messier Marathon posters. Feel free to say hi if you're in if you're in Casca, and if you are interested in doing some observing of our planet Mars, that's we've been talking about for the whole first half of the episode, I will just mention that Mars is in the sky currently, but it doesn't rise until very late at night or very early in the morning, depending on how exactly you want to count it. So Mars is a little bit close to the moon and not terribly far away from the sun. So you have to catch it just before the sunrise, which will probably mean around 4 o'clock in the morning Toronto time. So might be a bit of a challenge, but you can get it if you really want. All right. So let's go ahead and get into some news stories. There is so much going on this week. How about we start off with a little bit of the parade of planets, and then we'll talk about some misconceptions of the planetary alignments. So I mentioned Mars, and that's because it is visible just before sunset. But this is June 3rd, and today, June 3rd, before sunset, so that would have been 4 a.m., we had a six planet conjunction. And this has been called the Parade of Planets. Now, the six planets in particular were Mercury, Mars, Jupiter, Saturn, Uranus, and Neptune. And they're in a line with a lovely crescent moon. Any number of planets from 3 to 8 constitutes an alignment. 5 or 6 planets assembling is known as a large alignment, but 5 planet alignments are more frequent than 6, and so on and so forth. So 6 planet alignment is interesting. But of course, with not all of these planets are actually going to be visible to the naked eye. So, what's happening with the alignment? Occasionally, planets will appear to be on the same side as their sun uh, with respect to us as they move along their orbits. So, what's happening is, of course, the Earth and all of the planets are going around the sun, and we're looking out our big Earth shaped window out of the sky, and we get to look along in the direction of the nighttime. And as we look out, we can see whatever happens to be visible to us. So if the planets are, you know, arranged such that they appear to be on the same side of the sun as they move along in their orbits, we get to see them in the sky at the same time. And because we have no sense of distance, it all looks like it's in a straight line. And this is because they're all along what's called the plane of the ecliptic. So if you kind of imagine everything going around in mostly circles on sort of like a disk or a plate shaped orbit. So this is what's happening when I say an alignment for, a parade of planets. And today, or this morning, about an hour before sunrise, we had Mercury, Mars, Jupiter, and Saturn. But Mercury was pretty close to the sun. Mars wasn't too far away. Jupiter and Saturn were definitely bright enough to see with the naked eye. But Uranus and Neptune, whenever you hear anyone say they're part of an alignment, you'll need to get out your telescope or very good binoculars to see them. And if you're in the city, probably all you're really going to be able to make out is maybe Saturn, Jupiter, and if you're really lucky, Mars, if it's not too washed out. So it really is a 2 to 3 planets that you can probably see with your naked eye, and 3 more that you'll be very lucky to spot. But if you want to go ahead and have a little bit of a treasure hunt with your binoculars before the sun gets up, most of them actually will be visible tomorrow morning as well. So we have a few more alignments of the same planets coming up in the months ahead because, of course, they're all moving around their orbits, so they will appear to be in the same position with respect to us until we've all moved enough to where it doesn't look that way anymore. So you might want to mark your calendars accordingly coming up through August. We have got the 28th of August coming up, and 18th of January will both also have 6 planet alignments before sunrise. But there's a even better one if you're willing to wait just a little bit longer. A very good full planetary alignment after sunset rather than before sunrise. So much easier to see. All you have to do is wait until the 28th of February 2025. So alignments are fun, and I definitely encourage people to go out and look at them, but maybe with a grain of salt because you can't see all of them with your naked eye. And
Mm.
Robin, I know you've got some misconceptions about these as well.
Yeah, I'm so glad that, you pointed that out because there is so much hype going on right now in the media. And I heard a really interesting claim, and this was last week. It was actually from a teammate on my ladies' ice hockey team, and we were just sitting on the bench in between shifts, and she said to me, "You must be getting excited about this planetary alignment," because she said that she saw a TikTok video which claims that planetary alignments can cause aurora, so that we
Oh
might actually see
no.
both at the same time. So this is what hockey players actually talk about in between shifts. But anyway, so she tells me this, and I was like, well, I didn't know that. It sounds a little sketchy because a planetary alignment is really a visual thing from our perspective on Earth, right? Like it doesn't necessarily mean that the planets are lined up in a way that actually tugs on the sun. And that's the, as you described it, that's the current situation right now. So if you go online and you look up an online orrery, an orrery will simulate where the planets are. Then what you can see is that right now the line that's connecting all the planets, it does not connect to the sun, right? It's sort of perpendicular actually to the sun's location. So there's not this radial line emanating from the sun. But having said that, we know that the gravity of our planets do have an effect on our sun. They cause our sun to wobble slightly, primarily due to Jupiter's gravity. So it's not a totally crazy idea that if you have a bunch of planets and they're all tugging on the sun in the same direction, that maybe you could get tidal forces that are strong enough to affect the sun's magnetic field and therefore, lead to solar activity. So that's the claim of the TikTok video. But again, that isn't the type of alignment that's going on right now. But just out of curiosity, I looked into whether there was any research into a connection between like radial planetary alignments and solar activity. And I came across a Nature article from 1972, and then there was a follow-up in 1975 by the same author called Sunspots and Planets. And in the article, the author uses 200 years worth of sunspot data to show that when Earth and Venus and Jupiter and the sun are all in a line, that the cycle of that event, it matches the 11-year sunspot cycle. And not just in frequency, like not just do you have them, the peaks lining up, but also in amplitude, in the sense that when the alignment should induce the most tidal forces, you get the most sunspots. So it's interesting. And the conclusion of the article is that even though the sun's 11-year magnetic cycle is it's set by its own magnetic field, that perhaps the coincidental 11-year alignment of those four bodies is helping to regulate that cycle and also to accentuate it, like to dictate the peak or the number of sunspots. Does that all make sense?
Oh yeah, well, it is interesting because, as you say, the amount of gravitational influence of all those planets combined is so incredibly small. It's a
Right,
fraction of a fraction of a fraction of a fraction of um the gravitational influence of the sun.
right.
It's minuscule. And whether or not it's the alignment is related to it, or it's uh
It could just be
coincidental,
it could
or
be an observational coincidence because Jupiter's orbit is 12, just under 12 years, and the sunspot cycle is 11 years.
yeah, and
And
it's interesting
so
because, of course, it all evolved together, right? Because we
sure,
think that the sun and the planets actually were formed from the same cloud of gas, and
right.
as the sun, finished its collapse, its core collapse, and ignited, and started emitting light, blasting away the remnants of the solar nebula. These little planets were all that was kind of left after all the collisions and everything cleared themselves out. So whether or not this is a remnant of the
Mm-hmm.
formation of the solar system, or
Mm-hmm.
it's a coincidence, or as you say, it's just one small thing that could be helping to act as a clock or a clocked process or some sort of
Yeah.
tidal
It's
locking that we hadn't thought about before.
yeah,
Um,
the graphs are compelling. And so that paper didn't pick up much momentum, but since then, every few years, there have been papers making similar claims. And in 2007, there was a paper by a NASA researcher who showed that of the 38 largest known solar flares, 25 of those occurred when Earth, Venus, Jupiter, and Mercury were aligned with the sun. So again, some suggestion that the alignment might be aggravating the sun in some way. But then the problem is that people that actually produce models of like people that have tried to actually look for a physical cause, like to evaluate the strength of that combined gravity and see if you can get tidal forces enough to actually disturb the sun's magnetic field. So those models don't seem to be consistent with this claim. As you said, the strength of what we're talking about here is so small. So that's
Yeah.
the problem. But the observational uh, data is really compelling. So it's an interesting one.
Yeah, there's a lot of possible explanations, but even if it is coincidental or something that's evolved with it, it still might be enough to act as some kind of predictor, which is, I think, why some folks
That
are trying to use it.
absolutely. Yeah, that is the claim in everyone in the abstract in every one of those articles, is that we need to start being able to predict these things to protect our telecommunications infrastructure. But two other interesting false claims that were made in the video. So the first thing is, it starts out by saying, this is in the TikTok video, it starts out by saying this celestial phenomenon, as in what just happened this morning, will brighten the night sky. That's an interesting
Uh,
one. Second one, this is later, is that the release, that the combined, the tidal force caused by this alignment could cause a release of an iron-filled filament from the sun theorized to coalesce into a new planet. That was an interesting one too.
what?
Yes,
No.
and so then the host goes
Oh
on to
no.
discuss
Oh
something called
no.
the uniplanetary evolution theory. Have you heard of that?
I'm glad that you watched this video and not me because
So I never watched these things. It was just that
um
this particular hockey teammate of mine who I adore, and she's an extremely intelligent woman. I was intrigued by what she's watching. So that's why I checked this out. But if you know absolutely nothing about astronomy, right? Like it's not her field at all. She does other very important work. Then how would you know what to believe or not, right?
Yeah, and that's where fact checking is super important, and having people
Mm-hmm.
who can actually dive in and say, actually, that's not physically possible,
Right.
or actually, this is how it works. And the truth is, especially when you're dealing with things as complex as the sun's magnetic field, we
Sure.
still don't understand how the sun's magnetic field works in
Right.
some very, very key ways. The sun is incredibly complex. And planet formation. We've seen planets being formed all over the galaxy
Yep.
in other
Crazy
systems.
planets that we never thought could,
Exactly. And so we still don't
in crazy
completely
places.
understand planet formation. So there are some really interesting questions to be answered, but also you kind of
Sure.
got to kind of got to hope that at some point, at least there's the ability to fact check some of these. So I'm glad she
Yes.
asked you.
Yeah. 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 It was a fun little rabbit hole for me to go and dig into.
Oh, absolutely. And it is interesting because, when other stars like our sun go through similar cycles with sunspots, they don't have 11-year cycles.
Right,
And
exactly. Yeah. So that would be so interesting to look for similar connections between the orbits of exoplanets and their sunspot cycle.
yeah, and I mean of the sunspots that we have been watching around other stars, which I will have to say is
Hmm.
incredibly difficult. I don't think any other really regular sunspot cycles have been noted.
Ah, interesting.
At least not that I've read of. So maybe if you've read of
Yeah.
one, tell us in the comments, and we'll.
Uh-huh.
But it is interesting that our sun has such a beautiful, regular, calm behavior compared to what we see around other stars. And if
Hmm.
if our sun didn't have that, it would make a lot of things more difficult, like our
Hmm.
current electronics and this broadcast.
Among other things, but yeah. Interesting.
All right, so let's go ahead and get a couple more news items in while we've still got some time here. Since we were talking about Mars and we were talking about the moon just a little bit ago. I did want to add in one more treat for observers, and I suppose aficionados of um, uh, solar facts and moon things. So this is June, and we have this month coming up, June 20th, the solstice. So we get to look forward to the longest day and the shortest night, and then we get to look forward to the nights getting longer, which would be great for observing more things. But we also actually have a pretty interesting one this month in that it is the shortest lunar month. Now, this is an odd one because we have to talk a little bit about. We've talked about, the planets, of course, moving around, the sun and how that can appear from alignments, but the moon moves around Earth, but it doesn't move exactly the same way every time. It actually has months that are shorter and months that are longer, and months can be counted different ways. Do you count the month of the moon from the calendar? Do you count the month of the moon as the time it takes for it to go through its phases from full moon to full moon? Do you count the month of the moon from the time it takes the moon to go from node to node where it's aligned on the ecliptic? Those are actually different amounts of time because space is weird. And as a fun one, this month or this month, starting at the third quarter moon, so you don't get to start at a nice even one. You have to start on the third quarter moon of May 30th, and the moon will go around the Earth as fast as it's ever going to go for all of 2024. So this will be 29.19 days, or 8 hours and 10 minutes faster than average. So this
Hmm.
is the shortest lunar month of the year, this May 30th until June 22nd, which is just after the solstice. So we get this kind of cool thing happening this month. We have the solstice coming up, and then we also have the shortest lunar month of 2024. So as you look out at the moon, if you're trying to see the planets, the moon's right there in line with it. Maybe take a moment to appreciate just how
Mhm.
fast it's going around, because this is the fastest that it's going to go for all of 2024. And this is
Wow.
because the orbits are not perfect circles. So the moon is going around Earth in a circle-ish, but it's not exactly a circle, and it gets closer and farther away. So the orbital speeds change, and orbital speeds constantly change. So we actually have a couple different things that affect how fast the moon goes, including Earth's distance from the sun, which is nearly a circle, but not quite. The moon's distance from Earth, and of course, when the Earth and the moon and the sun are in alignment, you do get appreciable gravitational effects. And that's how we have tides on Earth with our oceans that we can all see. So, if you want to know how big something has to be to make a tide on the sun, you need to make it as big as the moon is to us, but for the sun.
Mm.
So, it would have to be massive. And that's why all the planets don't make any gravitational dent, shall I say. But it is still really, really interesting. And of course, with our shortest lunar month of 2024 and the solstice coming up, it's just a great time to go stargazing. So that's, anyways, that's a little bit of fun that I thought I would show into at the near the end of tonight. And we have all kinds of stuff happening with this. So in terms of what to do next, do you want to talk about the aurora? Since we did mention them before.
Sure. I mean, with all the craziness going on in June,
Yeah, so
that's another
planetary
one.
alignments, planetary
And
alignments definitely don't cause them, but the sun does.
yes, but yeah, well, it's going to be like this for probably the next year or so, going through this solar maximum. I'm sure you've talked about this on the show already,
Oh
but
yeah.
and I'm sure everyone is hearing in the media every few weeks that, new monster solar storm increasing the possibility of aurora. I've encountered people that have all sorts of cool apps on their phone that are like aurora forecasters, and their phone will start buzzing if there's high likelihood of northern lights. But I actually saw my first aurora on it was May 8th, right? That we had the big one. Uh,
Near then. Yeah, yeah, that's about
yeah,
right.
first time ever in my life. And
Oh,
it was not far from here. I was just north of Georgetown, and I was with a group of people, and we like my astro people, and we had heard that there was a storm and high likelihood of seeing northern lights that evening. And so we first as a group, we went to this one kind of dark spot. I think it was Milton. And it was funny because none of us had seen one before. And where because we weren't that far north and it was a little bit cloudy, you we didn't actually see colors. It just like white wisps. And we thought maybe we were seeing something in one part of the sky. And because your eye doesn't detect color well at night, if you take a picture with your phone or a camera, that's when the colors pop out. But to your eye, it's just going to look kind of whitish unless you're further north where you can see all the colors, right? So we're seeing these wisps, and we thought, oh, maybe that's it. And we took a picture in this one part of the sky, and we all saw on our phones that it showed up pink. There was this pink blob, and we're like, oh my God, we're seeing an aurora for the first time. And then we wait a little bit and took more pictures, and then that pink blob turned blue, and it was the exact same shape as before. And I was like, okay, this might be my first time, but everything I know about aurora tells me that it can't do that. And so we looked at where we were on Google Maps, and we were facing there's a casino out there, and it was the lights that the casino shines into the sky. So we were so embarrassed, like all astronomers, right? But we just had never seen the northern lights before.
oh yeah. Well, I
um
mean, that's a very natural error because I mean, it
yes.
especially I mean, so many people have had that problem. I think don't even be embarrassed because like if you
Yeah,
don't
I should
know.
show you the pictures. They actually are compelling. But anyway, then a subgroup of us broke off and went further north of Georgetown. And then we could see these white, like they were clearly not clouds. They were these elongated wisps. And so when we took pictures of that, it was very obviously aurora. Like the colors were coming out exactly the way they should. It was all around the sky, greens, and that was pretty amazing. I'm not nearly as amazing as many people I knew who were further north, particularly around the Georgian Bay area. And the pictures that they sent me, you probably saw this as well, Lena, but they saw a really spectacular kind of aurora. I think it's called an aurora corona, and it's where the lines all converge right above you. And
Oh,
those
nice.
those pictures were spectacular, not like the kind of aurora that you tend to see in photos and time lapse videos. It was very, very cool.
That is awesome.
Anyway, what about you? Did you happen to see
No,
any
I
northern
I
lights?
actually still have never seen them. I
Oh, well,
I
you'll
tried a few
definitely get
times.
your chance over the next year.
Yeah, and that is something to remember for folks who are interested. The NOAA has a wonderful Aurora
Oh, it's
Watch
amazing. Yeah.
that I totally recommend. Good forecasts with good lines of visibility where they'll kind of show
Hmm.
you if you're in the region that can get viewing. Generally, if you can go north, your chances will just increase.
Hmm. Hmm.
But it is a great time for it because, of course, this solar cycle 25, and this is when the sun's activity is supposed to be swinging back, and it definitely is. We're seeing a lot of that, and the increasing activity. We're actually not sure if it's gonna keep going sort of through 2025, or
Hmm.
stop after the summer, or maybe even, all the way to the next summer. So we're not sure exactly how high this maximum is going to get, um,
Yeah, yeah,
but it
the
is one to watch out for this summer.
yeah, the graphs are interesting because they show that we're seeing heightened numbers of sunspots a little bit earlier than predicted. And so as you said, that could either mean that the peak is earlier than we thought, or it could mean that the peak is on time and it's going to be higher than initially anticipated. So possibly due to a planetary alignment. No, I did not just say
No, no.
that.
And we're not going to say that here, but I will just say that, thanks to
I will
our
not
telescope
spread conspiracy
observers,
theories.
we have managed to pull up a live image of T Bor, which is the proposed supernova candidate, on the 1 meter telescope. So if you are following along over on YouTube with the visuals, it does not look particularly spectacular because it has not gone supernova yet. but that we are able to actually finally bring, for the last couple minutes of the broadcast, a little bit of live imaging on the telescope. So there was
Very
too
cool.
many clouds until right now. So if you do want to see live images, it's just going to be the last 5 minutes, but we'll make the most of it. And I also want to give a little bit of a shout out to anybody thinking about looking for any planets or comets or alignments that we've been talking about.
Oh
If
yeah,
you
that'll
don't
come. That
have
you'll be talking about that, I imagine, in an upcoming show. There's a comet soon to be naked eye.
Y- Yes, and
Hmm.
if you don't have an orrery, there's a wonderful free website called theskylive.com that
Hmm.
basically gives you a model of the solar system, where the planets are way bigger than they actually are, but they're big dots. But it shows you how everything's lined up, and it shows you the comets, and it shows you the plane of the solar system, which I always thought was really, really, really cool. So if you don't have access to an orrery, I definitely recommend the skylive.com in addition to the Stellarium web online, as free resources that are very good at showing off stuff. Now, there's one more thing about Mars that I'm going to stick into the show tonight because we actually had some really cool Mars news come up just recently, where they had one of the newer orbiters around Mars, NASA's Mars Reconnaissance Orbiter. It has a camera called the HiRISE camera, and this is actually a little fun bit of a trivia, because the HiRISE camera was built in at the University of Arizona. And this one was actually built around the time that I was there as an undergraduate. So it was pretty fun. I can take zero amounts of credit for it, but I did get to see it a little bit in action, which was pretty fun. Being able to see mock ups and actually see it in action, of course, now on Mars. The Mars Reconnaissance Orbiter, for those of you who are interested, this one was launched back in 2005. So when I was back in olden times, when I was at the University of Arizona, this was a really, really, really big deal. And the high-res camera giving those first high-resolution images of the Martian surface, getting down to the level where you could resolve something that was within, um, a meter in size, was unheard of. And this is why we are, continually orbiting Mars with this camera, trying to get more of these beautiful high resolution images, going back and re-imaging interesting crater walls that are, gushing with geysers of water. And they found recently a hole in the surface of Mars. And this looks like a sinkhole. It looks nothing so much as like a sinkhole. And the news articles that you'll see will be like a hole on the surface of Mars. It's a cave. What is it? The current thoughts are that it could be sections of lava tubes, or collapsed sections of lava tubes, because it looks a lot like structures on Earth that have occurred near collapsed lava tubes. And it's found near the previously active volcano area. I mean, Mars's volcanoes were active a long, long time ago. But in Mars's low gravity, if it did have lava tubes, it would have been able to make some pretty massive lava tubes. And collapsed sections of lava tubes are called skylights.
Mm.
And the thought is these might be pre-made, ready to go shelters that maybe astronauts could stay in that would protect them from things
Wow.
like the radiation and the harsh environments of Mars. And it's obviously we don't actually know because we can't see inside, but now we know where at least one of these things is. If we can get confirmation that it is a stable lava tube, it might be a very, very tempting location for future humans on Mars. So
Hmm.
I just had to put that in with today's Mars
Interesting.
oriented episode.
Sounds homey.
Yeah, well, if you're gonna go to Mars, you do kind of need to build
Right.
your
Are
base
those
underground.
things, do we have those on Earth that we can try to
Yes.
experiment how one would turn one into a comfortable home?
Well, we have them on Earth. The problem is that on Earth, our volcanoes tend to be active.
Right, right,
So
right.
most of the ones I know are around Mount St. Helens, which is on the west coast of North America. And of
Hmm.
course, we have some lots in Hawaii and places like that, volcanically active places.
Hmm.
Mars's volcanoes have not been active for a tremendous time.
Hmm.
So
Convenient.
they would be safer to explore
Hmm.
in theory, as long as they didn't collapse in on you.
Hmm.
But whether or not it's a lava tube is still under debate. But if it could protect habitats from temperature swings, radiation, micrometeorites, this would be an amazing place to build a base. So, it's a big if, but it's a very tempting if.
Neat.
I thought so. All right, so one extra shameless Eclipse video plug here at the end, and then we're gonna have to end the show. So I will just mention everybody. There is a wonderful video that Robin has done for chasing the 2024 solar eclipse. If you search on YouTube, failure is not an option, chasing the 2024 solar eclipse,
It,
it will pop right up.
will it? It's actually not public. It's it's only if you have the link, to my knowledge anyway. But it is on the York Eclipse page on in my blog area.
Oh
Yeah.
yes. So on the
Yeah.
on the website that they have before, they can go to your blog area and find it there as well.
Yeah,
And
and
we can
it's
actually
just
put the link in this video description.
that'd be great. It's for people who have never seen a total solar eclipse. It's really cool. It really captures exactly what was going on in the sky, and then superimposed on that is the photography that my group members took with a variety of equipment, DSLRs, solar telescopes, binoculars. So you really get the full eclipse experience.
Amazing. All right. Well, you heard it here, folks, everyone. And we're going to have to end on that happy note. You have all been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Robin Metcalf and myself, Elena Hyde. You can always connect with us on Instagram or Facebook and check out our website for show notes, content updates, and contact info. And of course, Robin Metcalf's wonderful Eclipse blog video, which is on the Eclipse 2024 website, just right on the same area. So yorku.ca/science/observatory/eclipse 2024 if you want to go straight to the video. And thanks for tuning in, everyone. Clear skies and have a good night.
Hello, and